Hello, possibly. Hello, and welcome back to making a 2D physics engine. So I went over all theory things, and now I just gotta do the rest of the things. I also got a message from Live EDU today, or Live Education Network, or whatever they're calling themselves now. Alright, that's back up again after the rebranding of the rebranding. And it's a whole new place again. And now telling me about how awesome it is and how I should totally go over there and join them and stuff. And then... no. I mean, you don't have to pay to view anymore, you don't have to pay to stream anymore, so that's great. I mean, in terms of on the way to back to how it used to be. Well, actually, it's still terrible. But yeah, it's all about tutorials. You gotta, like, submit... You're literally creating a tutorial for their site. That's all it is. Like a proper professional tutorial. They won't accept anything less. So I can't do anything like the random junk I used to do or do now. Yeah, that's that. But, I don't know. They're going on about how, oh yeah, but this is just for now and it could be approved and it's just a work in progress. I'm like, yeah, right. That's what you said about the last two. So far, you've just lost features more than gained any. Anyway, what am I doing? So, what exactly is the plan today? Now that I've promptly forgotten about all the stuff I rambled about the last 2 hours yesterday. So I have static, dynamic, and rigid collisions. So I want to do a static to a dynamic. I want to know if it's on the inside and to move it out in the direction of the vector that's being applied to it. So if I spawned two things intersecting like this, with the median points being wherever they are, this one will have a vector going down of gravity, which will then be inverted to go up by whatever it happens to be. So it's just going to invert its vector until it's outside the mesh? Yes, but no. Maybe? I mean, I could see how that would work. But this could also mean if you were, say, in the middle of a thing, there wasn't any gravity, and you were just moving left and right, you would just sort of vibrate within it, and you would never actually leave it. So I could do it like that, or I could have it move out in a direction away from the origin point of this. Or I could do both. So I could be doing this, but that could then override. So, because if I happen to be going in this direction, or the opposite direction, like towards the origin point, then it would be negating it, and it would just be standing still. So, I don't particularly know. That's all going to depend on certain things. Let's just go with what I want to do, which is the, make it move away in the opposite direction of its vector. So if it's inside of a thing, it's just going to invert them. Okay, that sounds fine. I guess. Sure, why not? Okay. So it's going to know which type it is, which type the other one is. So the first thing I need to know is define that. Is it a static, rigid, or dynamic? Then we need to know if there's a collision, inside collision thing, and then invert direct vectors to go away from it. Wait. I mean, yes. But no. No, that's not what I want to do. I mean, I want to do that, but that is sort of an easy thing and also a thing I will do later. So the first thing I want to do is know that this is going to be going down in that direction, so where does it intersect through time, and to have it be at that location. I've got that. Okay. And now I need it to bounce back in the opposite direction or do whatever according to stats, I guess. So if this was a static and that was a dynamic, and you had them collide, I need to be able to say like the density of this object or whatever. Is it going to bounce off it, or is it just going to plonk onto it? So, but that's stuff I could do afterwards. So I just need to know if it hits it, how much of its energy did it still have remaining for this frame, and to have it bounce off. Okay. How would I have a bounce off? Well, the first thing to do is find out the things. So, wait, is it going to be triangle or am I going to do the compound thingy? I guess I'll do the triangle thing first, and then do the compound thing later. I'll just have it so I just need to give it a set of edges. In this case, it would be all 3 edges. And then it will loop through, remove duplicates. Will I have it do that, or would that be a pre before that thing? So do I give it the set of vertices? Or do I give it edges, and then it removes the duplicate vertices and does this? If we have the edges, then we know which vertices are connected to what. Do we care? No. Okay, so I need the object, which in this case is a triangle. We're not worrying about compounds. So a triangle is going to move through here. I should really code it for the... whatever. It's going to move through there. And this one's going to also move back, because it could be moving in a direction where that corner intersects with this bottom, yeah, whatever. Which is just the same as inverting the vectors and saying this one's moving instead of that one. So we need to know object A, object B. Okay, let's worry more about the storage of things first then. So, well, the first things first, I need to know if it's a dynamic or whatever. The stuff can just go away. This was just for the daisy chaining sort of thing. Woo. So I could add more segments to it. Is that the one I'm looking at? Yeah. So that could be like 12. It's got 12 segments to it. Woohoo! Super chaos! That's just going to whip around for a very long time. The question is, will it ever change direction? I feel like it's come pretty close to changing direction a few times. Oh, it almost tried to then. So much fun. Oh. Nah. Well, so yeah, all of this junk could just go away. I was just messing around. So I have object 1 and object 2. I could probably get rid of the little highlighty thing of the background. Let's just change that to a 0. I want to say object is a dynamic. Where do I want to store this? Do I just want to say object collisions? Do I want to put it under mesh? I feel like mesh would be a great place to put it. So object mesh collisions equals whatever. Hang on a second. Feels like I'm getting a bit of a cold or something. I have absolutely nowhere. Where's music? I should put some music on. Can't find it. Are you over here? Are you over there? Are you over there? Nope, 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 nope. Yes. Maybe? No. Oh, I hate that high-pitched sound at the beginning of every single one of these videos. That one. There we go. Okay. So... I should probably open up my other chat too, in case someone talks on live D-Live. That's weird. Chat's not loading. There it is. Okay. Just gives me a history of the messages, so it's easy to see things I may have missed. Okay, so I would say mesh collisions. I don't see why not. Whatever. Collisions. The tabs are all out of whack. Yeah. Collisions. Oops. Yeah, that's where you want to be. Probably pause as well. Mesh collisions equals, this one would be dynamic. Let's use words. No. I really gotta clean up some tabs, don't I? So I want to keep the vector stuff there. Ah, it should be easy to find again. I like that one for some reason. That'll do. Okay. So dynamic. And you shall be static. Static. I believe that's spelled correctly. Okay, so we've got dynamic colliding with a static. Now we need to have that within, I'm doing the tick update thing. So this other one should just have that not be there. No, it has that be there, okay. Because we're doing this thing. So I could just remove all of this. So I assume that all of this should probably be in the object default stuff. I mean, I like to keep that one clean though. I mean, it's easy enough to remove, I suppose. So should I call it like tick update? And that could be my new standardized name for that, because normally I just call it update, but then update could have multiple meanings, because you also update when you resize, or resize update, but I just called that one update as well. it updates the objects on resize, because they could have something different about them, or size changes, UI limits and junk like that. I don't know, whatever. So, okay, so how do I want to go about that, I guess? Because one object's going to collide with the other one, and that one's going to collide with the other one. They both collide with each other, so they both have the collision. Should I have the collision check run for both of them, or just one of them that updates both of them? So, if I do it with one and didn't notice a collision, I got to also do it with the other one, just in case it happened to fall through the gaps, because we're just checking vertice locations for intersections, or interiors. No. This is the other one. So we want to know edges, because this is an over time thing. Okay. So over time, it still needs to run on both anyway. And if one misses, then does the other one. I could just flip the thing and go again, but do I want to do it by just simply running the other one's collision function with inverted objects? Or just do it both within this one. I feel like I want to run the other one's collision, because maybe it has some sort of a different reaction, but that's not going to be any good anyway, because the reaction for one of them would also change the reaction for the other one. If it happened to be a really bouncy material that reflects 100% of all incoming energy, then it needs to know, both objects need to know that that's going to happen, otherwise the other one will assume it's absorbing 50% or something. Or whatever. A percentage based on the mass difference. So, yeah. It's a percentage based on the mass difference divided or times its material. Yeah. So, if you throw a bouncy ball at a brick, the brick's barely going to move, but the bouncy ball's going to fly away. If the bouncy ball was instead made of the same material as the brick, then more energy is going to be transferred into the brick itself, the brick's going to move further away, and the ball will not bounce off anywhere near as much. And if the brick was made out of bouncy ball material and the ball was the same as the brick was, the ball would bounce away the same as if it was the bouncing material, I imagine. So you just need to know the difference between the objects, you don't care which one's what. So, okay. Things move at the corner of my eyes. So, I would have to know the material type, and the collision, and all, whatever else. So, okay, I would just do... no. Because this is the update of one object, not the update of the other one, because the brick is going to move away as the bouncy ball bounces away. The bouncy ball hitting the brick could update its own thing, and then the brick works out stuff afterwards with its own functions. Or I could just have the bouncy ball's collision function update the brick's vectors. So, is the ball interacting with the brick? Or is the ball and the brick both interacting with each other? If it's with each other, then I would have this function separated. If it's one interacting with the other, I mean, they're both valid. They're both the same. Okay. So a static object is basically an object with near infinite mass, or something like that. So I can use the same calculations for both. A static on two dynamics or two rigids. Well, rigid's more complicated, but anyway. So what do I do? Oh, derp, I lost my train of thought. My visualizer's broken. So if I have the ball interacting with the brick and doing it all within the ball's function, and the brick's functions never even run other than to update its vectors, if that's a thing, then okay, let's take a step ahead. What happens if there's multiple collisions going on for an object on the same frame? So if the ball hit the brick, but there was also 3 other balls that happened to hit the brick at the same time. The first ball hits the brick, it updates its things and the brick's things accordingly, which could actually move the brick away from a different one. So it would just be the order of priority of that. Alright, post to join for ask questions if you want to know what's going on. So when I just loop through the object, store a variable of the every object that has already interacted with every other object. So the first ball has already interacted with the brick. Then if we have the brick do its thing and it sees ball 1 interacting, which it already knows happens, it's already accounted for, so forget about it. It just simply won't even check to see if there was a collision, unless it has changed. Okay. How would I do this? So, the first ball hits the brick, the ball bounces away, the brick's information is updated, the ball's information is updated and applied. So if anything wanted to check against... No, because that's going to depend on ordering. There could be 2 bricks that the ball could hit, and it's checked the one that it wouldn't actually hit because of ordering. It could, like, 2 bricks within the same frame that it could hit. It doesn't know which one's in front or which one's behind, it just knows which one it's going to check first. So if it checked the back one first, then it would never know that it even hit the first one, and the back one's update could make it bounce away, so it never hit the first one if it hit the second one, and then suddenly put the first one there. Anyway, so that's also not going to work. So I need to check all things for a collision, make a list of the distances to each of those things, like all possible collisions, make a list of the distances, sort that by closest, update according to the information of the closest one, and then rerun its collision thing to see if its new vector is going to collide with something else. And I assume update the vectors of the things it did collide with. Okay. And then I'll continue doing that until it runs out of energy. And then I can move on to the next object. So there's another problem. I'm not going to continue doing that till it runs out of energy. I'm going to go step by step until all objects have run out. So every increment of updating of an object, it will then just go to the next lot of stuff and then loop around. Okay. And by doing that, because the ball could hit something, and that sets off a chain reaction that's going to move something else into its path on that frame. But if I don't update the other things, the chain reaction never knows that it even existed. The ball would be moved out of the way of the chain reaction that it would have otherwise hit. And that would cause a weird graphical glitch looking thing. Okay. So, other problems. I only know where an object currently is. Hello, post to join for free ask questions if you want to know what's going on. Because I only know where an object currently is and is going to be, I only know to check the things on the intersecting tiles from those two locations. I can get the tiles on the in-between ones as well, but they will only be the static versions of stuff, not the dynamic versions of that stuff in motion. So that's complicated. I knew there was a whole lot of stuff I didn't think about yesterday. So I need to know all tiles, all objects are on and intersect with over the course of their movement. So the first thing I need to do is get what they are, get where they're going to be, and all tiles between, for all objects with a vector. Then the next thing I need to do is check to see if any of those overlap. If they do overlap, then I can get the vector information to get the collisions of the objects in motion. And if they do collide, I can update its vectors by a step, re-update the collision grid, then just loop through all objects. When all objects are looped through, I would just loop through them all again with their new updated vectors. Unless an object required to be updated a second time because it bounced off of something, moving into the path of something else, which then was being checked, so it would then have to update its vectors again, so it technically would do 2 steps in one frame, or one go. Which isn't a problem, I guess, it's just going to be what's going to happen. Okay, so I could get into near infinite loops, or actual infinite loops of stuff like that happening. So, I want to make a list of every single object, objects which have currently interacted. No. If an object has interacted, then there shouldn't be a collision because its vector has been changed unless it happened to intersect with the inside of an object. Should that ever happen? No. We should never have 2 objects inside of each other from a collision. Only we could if it was inside before we even started the collision checking. So I'm just going to assume that that's not a thing. Okay, so I need to get a list of all the objects. Don't need to know if they've interacted, I just want to know how many times they've updated their vectors. And if one updates over a certain amount of times, then I could just ignore it because it could be an infinite loop of an object fitting perfectly into a space. Which technically still wouldn't be infinite as long as there was a Browning effect, because it should be never perfect for the amount of energy between stuff. In real life, you collide 2 things together, some of the energy is converted into heat and other entropy sources, whatever the word is. Yeah, I'll slap at a chicken to cook it. The current meme? Nah, that meme's dead now. Okay. So, I guess I'll just build that in by default, but still it can loop quite a lot of times because of the amount of a vector that there is. Okay. I could store that information within the object itself, or I could create a separate instance of all the information. No. I would just store that within the object itself. But that means ifs and stuff. Where am I going to store that? It could be within the scene. That means I'm going to have a specialized update just for collisions. Collisions need to all run at once on a certain step. Okay. So I could just have that as a function within the scene. It could be a specialized function within each object. If an object has... Oh, my table's vibrating. Should be a bit better. A specialized function within the scene just calls all the objects. If the object has a collision check function, then run that function and add its name to the list. And if it collides with something, then I need to return the object it collided with to also be added to the list. I think that should be good. So the tick update is going to be updating vectors. Okay, so that's a new style, because I've just got everything going chaotically, just whatever order it happened to be created in with the delay function updates. So I'm going to have a specialized thing for the scene. Okay. Now I need to have layering priorities in jump, which ones are going to go in what order, and other things will have to be before or after this stuff. Yeah, that means this stuff's all going to go first, so I need to prioritize things with categories. I did that at one point. My delay function was able to have a priority system. How did I do that? Was it a different delay function setup? Where would you be? Better person to join if you ask questions if you want to know what's going on. Let me know if something's bad with my audio or something. People keep joining and leaving. Maybe it's just boring. Okay, that's it. So this one. No. Okay. Write a check. Delay function events, so that's keyboard and mouse events, delay function, and delay function buffers? That's a set timeout. Delay function buffers. Buffers. What are you again? So I'm assuming this is stuff that has to wait until the end of the frame. Where the other stuff continues on during this frame. That wouldn't be picked up by my delay, my debug system, would it? Did I build that into something? Okay, so maybe I just built the priority system into delay functions? Oh, let's go delay now. So many systems. I have to keep track of all these things. You don't seem to have any system priorities. Okay, so that's before rendering, after rendering, and to the next frame maybe. Okay, and then events. I didn't even give that one a proper name. What are you doing? I mean, you're not really delaying an input event, you're more collecting them. It's a buffer for them. So it's buffered input events. Runs buffered input events before rendering. I guess I'll add a buffer. Gotta have a buffer tag if I'm mentioning buffers, I guess. Okay, so do I want to recode how my delay function system works? To allow me to be able to prioritize things by certain stuff. So I could just give it an extra input after arguments. By default it will be undefined, otherwise it is what? Why am I doing this? Does this matter? So as I said I'm going to do, so I'm going to, yeah, because I'm going to be running update vectors, or the applying of vectors, the collision update, or collision checks, and possibly other stuff. So if I have this in some sort of a priority system, I can put functions in between those things if you wanted to override stuff. Don't know why you'd want to, but that could be a thing. Hello person, join, feel free to ask questions if you want to know what's going on. Maybe I should just not care about that. I mean, it's a thing I can do at any time, but I'll actually be using it, so whatever. Okay. So, oh yeah, no, that was the reason I wanted to do it, because I could, if I just add this stuff to the delay function, then it's all going to be, collisions and vectors are going to be updated before any functions that you add within. No. Because the delay buffer just adds things to a list. If the first thing I add to the list is the updates, then anything else that could change stuff, like locations, false overriding locations and stuff, would be happening after it's already updated the locations of the collisions, which you may want to be the other way around. That's the problem. But this is happening on the next frame. So the first frame, it's going to be at the beginning, and then it's going to be running the things that were delaying for the next one. And if it was a... is it going to be inverting it for the second frame? It's just the first frame that could be... no. Okay. So I want this stuff to run at the end. It needs to run at the end. I could just dump it into this thing, but this thing has problems. So it's going to be before render, but after delay functions. I don't want to add things to the delay now. What does delay now do? Delay now delays to the end of the current frame rather than the beginning of the next frame. Is that what that's supposed to do? Was that what that was supposed to do? I mean, they wouldn't be both in the same area if they were. Do I just make a new delay buffer? Or do I add a priority system to the delay buffer, because that would then be a use for that? Or do I just say if you want to do it before, you got to say delay now rather than the delay buffer function? Yeah, I think I like that. So if you're adding it to the delay function, it's going to be running after this stuff. If you want it to run first, it's going to be delay now. Okay, that seems like it's good enough system. We've got a before and after, we don't have to change priority systems. Okay. So, what am I doing? I'm adding this to the scene. This is going to be a 2D scene or whatever, so... Scene! Dot... Tick update. Okay, I like that word. Tick update. Scene. Delay. Function. Scene. Scene tick update. Scene. So this will run every single frame, and you also want to continue doing this every single frame, unless otherwise told not to, such as the pause event. But the pause event... how do you work, damn it? We would still want this stuff to go. Does the pause event do stuff? I haven't used the pause event for a long time. It's just delaying keyboard events. We would also want it to stop the updating of collisions. I'd rather not have this in multiple places defining what the pause toggle is, but I don't really see a problem with it. Whatever. So, we want to loop through all objects within the scene. So that means an object has to be within the global storage within the scene's information. Yeah, I guess. I mean, it's going to be somewhere. It's going to know what's what. So, for scene objects. These. Check to see if the chat's still working. Well, here's the object. Object, insert objects. Object is object. Object dot collision check. Sure. Okay. After this, we would then basically want to loop through the whole thing again, and we want to do the update of the vectors. So I guess that could be a thing of its own as well. What is this exactly? Could I embed other things within the same function? What is it doing? It is updating the locations of the objects according to the vectors, knowing that collisions are all good now. So it will end up where it's supposed to end up. Is there anything else I'd want to be doing at this time? I don't foresee anything, so sure. Vector update. Is that what I want to call it? So it's updating the vectors, which is different from an update vector. So an update vector would be changing the vector to be something else. Vector update would be updating things according to the vectors. So, naming convention seems fine. Okay, so then we also need the collision checks. Okay. So I'd want to continue to loop this until we have fully updated all collisions according to whatever junk. How do I want to do this? So the information I want to know is how many increments to the collision updates has it done, so I can avoid infinite loops, or loops that are just too high. And I want to know what the object is, so what object, how many times it's looped. And I want to know what's left to loop. Okay. So I can optimize this by first looping through this and making a list of all of the objects. So let's check collision. Oh, checklist. That's good enough. Checklist is equal to an object. And no, I don't really need that much. Scrap this. Whatever. I want to loop through all the objects, add them to the checklist. So the object, we just need your ID, so you can just object, that's nice and easy. Equals 0, so we want to know what the object is, and we want to know how many times it's looped. Start off with nothing's looped at all. then we can just loop through the checklist, object being the ID of the object we want, so that would just still work, that would work fine to grab the object, same, or the same, the collision check will return information about stuff, so I'll have everything within the collision check function for what it's going to do, and it's just going to have to return stuff accordingly. So if it returns, say, a 0, then it had no collisions, and we can remove it from the checklist. Okay. So this would then become a while. While checklist. Can I do that? Not sure if I can do that. Whatever. Away. See. Zero. C plus if C greater than 10. Yep, that didn't work. What if it's just because of R? That one will work, but then we don't know what B is, which was on a different line. Yeah. Okay, so I need to know what thing is. We still need to loop through checklist. This is just going to continue for as long as there is checklist. So for object in checklist, this is just going to be while checklist is a thing, or has a length, has its content, because that works, right? If A A equals object. Damn it, so it was a thing. It was also a thing. Huh. But if I say this, that should not have been a thing. Ow. Why does this keep changing on me? Okay, I'd prefer to not do anything fancy with that while. But I need to know if there is something within the object, which I have a function specially for that, so OBJ true. Just a simple loop for I in whatever the input is. If it loops, then there's something there. If it doesn't loop, then it just doesn't loop. So on the first index, it just returns whatever the first index is. Which could actually be a problem. That old bag of worms again. you do still return I. You really should just be returning true. Which is why I had something else, object first, to get the first index. I mean, these probably still need to be updated. I mean, I don't really care. Okay, you know what, let's just simplify this thing, because I don't care if you're an object or an array. I don't care what your data type is. That's all you need to be. Whatever. Oh. Okay. Yeah, this could be running a whole lot of times. I'd prefer if it didn't have to do extra stuff that it didn't need to do. I'm sorry, it sucks that it's going to do that extra. Whatever. Okay, so as long as there are things within the checklist, object and check. I loop through the objects within the checklist. So the object is the object, and then you'll return whatever that function returns. So if the function is false, so if not A, as in you're just a 0, well, let's just say 0. Which can also be false. I think I just do triple equals. If you are literally the number 0, I mean I could have it as false, I guess. I'll just use these numbers. If you are the literal thing of false, then we could remove it from the checklist. Delete checklist obj. Okay, so instead of doing that, let's do that here, and then I can just delete that. Okay. I believe for in things will automatically account for a thing being removed. It won't be one index further than it should be. Okay. Else, if A is equal to a string, I could be returning an object that just contains information. I'd only ever be returning one thing though. Whatever. Do I call it str or string? Never know. Oh, it tells me whatever it pulls up, which would be a string. Okay, so if it's a string, then we're going to assume we've got a variable type. Okay, this is something. Object. So this is collided with something that may have previously been removed because it didn't collide with anything anymore because it didn't know about it, but something could have been redirected back into its path through the incrementing of the other objects. In which case we want to add it back into the collision checklist. So we would want to say that is equal to 0. This could cause another infinite loop. In which case, why do I care about the checklist equaling whatever? Why do I care about it equaling 0? Because I could just have a variable that's outside this while loop. What is that called again? the maximum amount of things. Whatever. No, because it was on a per object basis. So, a single object can't do it more than a certain amount of times, but other ones can. Well, I mean, if we're assuming that the whole... So that we'd... this allows you to intersect objects, doesn't it? Okay. So I could have it if it does it enough times, then its vector is just equal to 0. It no longer has any movement. If it's not moving, then it can't continue the loop of infinitely bouncing off stuff. The problem is that it could be setting off a chain reaction every time it does bounce off of something, but then it continues looping itself. Then it zeroes itself out, which then makes whatever it hit move. So if I just had literally a square inside of a square hole, both things were exactly the same size, minus 1 pixel or whatever, then the one on the inside would be moving around, giving a whole lot of energy to the one on the outside, and the one on the outside would then move, restarting the one on the inside again, which then restarts the outside, which then restarts the inside. Okay. So I could keep the number there and just toggle it off so it doesn't care about it if it's been toggled off. But it can be toggled back on again from something else, which would then continue up its incrementing counter. And if it's maxed out, then it's just 0. It could be hit by something, but energy won't be transferred. That would stop it from intersecting inside of another object. And... okay. So what's my problem here? I'm supposed to join for free to ask questions if I want to know what's going on. Wow, the chat's going past now, that's weird. So I toggle it off and on, or I could delay it, because instead of it, if it's bouncing around inside of another object, that makes the infinite loop thing basically, or makes it just loop extremely large amounts of times depending on the amount of vector it has, which would just lag everything down even though it's basically not moving at all. The thing on the outside could move away because of other forces, so I should have it loop a certain amount of times and then stop. So it could only do X amount of times in a row before it just pauses and something else has its go, until we've gone around either to the max amount for all the things, or all energy has been used. So I'm not toggling it anymore, but I'm not removing things. I keep them there. So I will be toggling them. No, I don't need to toggle because the number will just be greater. So if the number is greater than a certain amount, then you simply do not update your collisions anymore and you get skipped. I guess it could never go down. So why would I need to add things to the list? because something that has no vector does not need to have its collisions updated unless something runs into it. If it has nothing ever running into it, it doesn't need to be incremented, so it just simply doesn't need to be in the list. But then if something did hit it and added some energy to it, a vector to it, then I would want it to be in the list, so it would have to be added at that point. Okay. Rather than looping through every single object in existence to check to see if it has a vector every single time of every single increment. But that also means I'd want to remove things. Would I? Maybe it's okay for things to be added. Things just don't get removed. It sounds fine to me. That's what that whole sleep thing is that games normally have. When it's asleep, it wouldn't be checked in this list, because it has low enough amount of vector things. Anyway, okay, so I just don't delete things. So if you are false, then I'd still like it to not check though. Which means it's got to be deleted. Okay. What if I created a secondary list? If it's deleted, it goes into the secondary list, and then if it's re-added and it was something that's in the secondary list, then you can continue on from where you were, remembering what that number was. Sleepless. I love it how those are both exactly the same amount of letters. Okay. So if something's deleted, it's also added to the sleep list. Okay. Then if something is added, if this is within the sleep list, else. Then again, I could just have that happen. Don't need an else. So that's just equal to 0. If it's within the sleep list, then this is then equal to whatever it was in the sleep list. Okay. Then when it's deleted, it'll just be re-added back to the sleep list again, which it's already there, so it'll just override the value. And that's great, I don't need to care about deleting it from the sleep list. So there we go. Then I just need to simply add the if this thing is greater than, let's say, 1,000, which is probably quite a lot, I don't know, then continue. Let's press that I. Continue. Because we don't care about this. Which I could actually delete it from the checklist and move it to the sleep list. But chances are, if it still had force on it, then things are still going to be colliding with it in the infinite loop thing. Although, when they both reach 1,000, it and the one that keeps colliding with will both be added to the sleep list and forgotten about. Unless something else bumped into them, and then it would activate both of them and then sleep both of them again. And I feel like I should just keep it in the sleep list, in the checklist. I don't think it would add too much to the performance. I'm not sure if this would be better or worse than performance. I mean, one's adding and removing variables constantly, and the other one's checking a variable constantly. Now, this would be more efficient, I think. Unless this is a certain condition that's extremely rare, in which case, even if it did happen, whatever, who cares? Just gonna do it that way. Okay. So what have I done? The scene has a tick update, so every single tick will update the collisions by first getting a list of all of the objects that need to have their collisions update and how many times they have been incremented. Then we loop through them all, incrementing them every time it gets its collision checked. The collision check will return either a 0 or an object. If it collides with an object, it will return the object it collided with. It could be colliding with multiple objects, damn it. No, it'll only ever be colliding with one object at a time, whatever one's the closest one for that increment of the collision check. So it's either going to collide with nothing or collide with an object. If it collides with nothing, it spent 100% of its energy, it can go to the sleep list because it's not going to be moving anymore. Unless something happened to be diverted into its path. Okay, in which case it would have collided with something, well, something would have collided with it, and it would be the thing that the other thing is returning from its collision check, which would then add it back to the checklist from the sleep list. Okay. So that's either going to return a 0 or an object. If it's already in the... Oh, that's a point. If it's already in the checklist, so I need to check that as well. And that is not a thing. Nah. Equals undefined, because it can be a 0. So if this is undefined, then it's not in the checklist to be added to it, otherwise it would be overriding it from the sleep list if it happened to have gone in there once, and that would have created the infinite loop again. Okay. Once all of that is done, I can then update the vectors to the locations. I can do the vector update for all of the objects that contain that. I'm just going to have the function itself check if it has a vector. I don't care about doing it beforehand. I mean, I could do it beforehand. Would I? I feel like I could definitely put more into this function than just updating vectors, but I mean, I guess I shouldn't. It would be different functions. I don't know. I feel like the updating of the vector goes to other things. Whatever. We may as well then. So if obj vec 0 is not equal to 0 and 1 is not equal to 0, well then I have the sleep ranges as well. Whatever, and this also needs to be apps. Let's just do it here. You know what? No, let's do this in the updating of the vector. Let's keep this area sort of clean. I mean, this should all be in, but this is the... whatever. Just to make everything look a bit cleaner. Checks. I like doing this. Just for the sake of it, lets me collapse it. I guess this actually should be applied. Let's just call it vec apply. I always call it vec. I'm probably spelling it wrong if I spell vector. Yeah, vec, right? Vec apply. So I do collision checks, then I apply the vectors. Okay. So now I need to make the collision check, which was what was in which is what is in here. String? Oh yeah, for the string. Pulse. Okay, so that's going to need a recode, and this would be the vec update. Vec apply. Which, again, okay. Let's just copy all of this. Okay. So, Move that down into here, so it's all instanced towards everything, for everything. Maybe j dot quick apply. That is what this is. And that's a collision check. I was going to keep that in there for now. I mean, that's more of a complicated thing. How would I do stuff like that, I guess? I guess that would be more advanced collisions stuff, whatever. Different collisions. No. Been that long already? What am I chatting about? Oh. Apparently there's 2 people in here. Let's refresh my chat. Out of here. Alright. So... Vecfly, and this would be... It'd be ga dot... collision check. Okay. So Vecaply, we're gonna have a Browning effect, but let's not worry about that for right now, I guess. We're not caring about the string thing, so we want to apply gravity to. Oh god, gravity is going to be applied. Okay, Vecaply is just this. How do I do that? Okay. So I guess in this case, gravity is a global thing happening to all things within the scene, so I can do the same looping through thing to apply constants within the globals. But what if I wanted to do something different? I don't know, what if I had it so it worked on gravity where this variable wasn't just this, so it would be different for every single object, and then the global would be whatever. I prefer to not do that. Okay, so I could buffer all of the updates to vectors of objects and have them apply or update before the collision check in a separate updating thing. Or I could just have them all happen within a delay now. That would also work. So... okay. No. Maybe? Okay, so I can keep having a tick update. The tick update's going to apply gravity. Oh, I do like the idea of the global thing though. I mean, it would only really be used for gravity, I guess, but... constant things for all things. So I can say obj tick update. Which is not actually a thing right now. Whatever. So the tick update would be the thing that adds gravity to this. Let's just get rid of that. So this is just applying. The applying would just be this part of it. And that is basically just junk. When it's applied, you're going to do that. So there we go. Okay. So this could have more complex things for compound shapes and stuff like that, I guess. So there could be more information to go into there later. So now I gotta do the collision check stuff. So how does this work? So we already got an object collision check, damn it. So this goes through and gets things that it could be colliding with. And then this is finding out the location the collision is happening. No. Yeah, so this is getting the possible collisions. This is checking to see which of the possible ones are literal. And then just sort of breaking it. Okay, so let's just move these together, I guess. I like it being the return thing though, I don't have to do any break stuff. No, because this is just getting the first collision. We need to get a list of them. Okay. So let's just have a check. So things that need to be checked for possible collisions. What is I? Should be the object. The ID. No, it's a tile I. Yeah. So I should be the ID of the object on the tile that it's seeing a possible collision with overlaps with the collision grid. And tile I should be the literal object. As this thing seems to do. Yep. So that's the ID, that's the object. This will remove duplicates because there will be probably a ton of duplicates. Although check actually stops that from happening. Whatever. So that should be fine. I've already got a system for that. So there we go. That should have every single object this could possibly be colliding with in the dammit. Okay, again, I'm doing passes. That's the whole point of the pass thing. Oh god. So, I already know all of the collision grid tiles the object is overlapping with. I now need to find out where it's going to be and the collision tiles that will be overlapping with. Then I need to find out all of the tiles between those. This is just getting the first step of the already known tiles. And it's just a bounding box. So we'll just do bounding box style, I guess. Somewhat less efficient, because it could be including a whole lot of empty space, as it does. There's a whole lot of empty spaces of tiles which are being overlapped with, but don't actually have any meshes over them. But to do an actual proper mesh one, I got to do the triangles over an intersecting that are intersecting over a grid thing, and that is probably going to cost a whole lot more power than it's probably going to be to just check those extra spaces. It's basically the same thing to check those extra. Okay, yeah, so that would probably be better. Okay. So I need to make a pseudo thing, because this is just a square thing, of all of the tiles that overlaps with from most to the least top corner to the other corner, relative to world space tiles. I need to add all of that to an object, so I can remove duplicates of where it is and where it's going to be, which means I need to work out where it's going to be given its location in the bounding box. That should be fine. So, tiles. Oh. What is this? That's assuming the end location, whatever. I'll get back to you. So we need to get a list of all the tiles. Tiles equals an object. Tiles are just X, Y, everyone's got a unique ID. If you have tiles, we need to get those, we need to get your X, Y thing. We don't care if there is or anything there. So we then need to push into here. No, this is the thing. We need to add this to here, so that will be your unique ID and also your location, but let's have the location be next, a separate thing. Just so I don't need to separate it out. So that's where you are. That would remove duplicates, when there possibly could be duplicates. And now we need to work out all the tiles that will be overlapping with in its next location. That's not how my tile thing works. Unless I create a pseudo object, but that will be adding the pseudo object to the literal collisions. So I guess I'll need to create a new state for that so I can just test rather than actually apply. Or I could just separate out the part that figures it out into a separate function and run that. Okay. The next step for this stuff would be to check to see if tiles contains anything, so obj true. If you contain stuff, this becomes a whole lot easier. Or in. Oh, we're gonna say tile, I guess. Tile and tiles. We don't need the extra thing. You could literally just be your ID for this thing, so you can just be tile. We have the location, that just gets overridden by this. We are using I. What is I? I is the thing within here. So we were never using X and Y directly. Okay. That should be all the changes I need to do there. Really? If we have tiles, we look through the tiles. Tile would be the ID. The ID is the location of the string. The location of the string is what location is to find out to see what the tile is. If that location is not a tile or is empty, no, it's just not a tile, because if a tile is empty, it gets deleted. So we have an object of only tiles with things on it that exist. And that way we can have infinitely sized maps without having to worry about infinite amount of empty coordinates. Basically. And yeah, then that just gives us the literal tile, given the ID of the location as a string. And there we go. Okay. So, yeah, now we just need to get the two, and then the connections between them both. So, how would I do that? Uh-huh. Look at that. Did I ever get my overlapping tile, line to tile thing working? Line to grid. I don't think I ever really did, so for it to work I need to round the coordinates to the intersection points. Either up or down depending on stuff. How would I figure out what that stuff is, otherwise it's going to be rounded. Or I could just add extra to both sides. But no, I can't do that. I'd have to know which one's on the outside, so I'd have to know the normal lines to move it out. Which, again, would have excess tiles to one side or the other. Probably both. A little bit annoying. Okay. Maybe I should try out that math again. I feel like my math is fine, but I never get it to work properly. Anyway. So yeah, I could get the start point and the end point fairly easily. So let's try to do that. What are you again? You are update node or something. Update node. So, update node, you need to get the tiles, we need to know the box bounding block because it's just location and size, and that does... So that's deleting it from where it was. And then this is how it works it out. And then we're looping through those tiles to add it. So this is the magical code. Really? I feel like that's something's missing here. Oh, because this just gives me extreme ranges. Oh, never mind. So that's how that works. So that would be a square to grid. Do I want to make a function for that? So it's getting what tiles a square is overlapping. A dynamic square. Static or dynamic? A static square. Should I? I mean, I've got all the information here, I can just copy that. Doop-a-doop. So I'd want to do that. And then we'd want to do this one. And I've just realized we could just say if not this or something. I mean, let's just assume that's always a thing. Why wouldn't that be a thing? Then I can just do this, and I don't think I really need that. Remove? What am I looking at? Oh, it's because I copied it from a thing. Okay. So we loop through, we add it to the thing, we get a different boundary, which would be the thing including all that other stuff that's also in here. In this case, we are not caring about the mesh. Oh wait, no, we need to care about the mesh to get its proper locations. Okay. Wait. This is updating location information. Okay. We probably don't want to do that. Say that. And object location could just be that. And size can be size. We're just looking. We're not touching. Oh, that's just applying. That's plus equal. Whatever. This confuses me. Oh, that one's plussing, but that one's applying, so yeah, fine. If it wasn't that, then it would be going to this one, which would be plussing, which would mean that it has to be something beforehand. Okay, that's all good. And...
Hey, wanna dance?
this would just be the thing that this would have to loop. So let's just call this range or something. Range. Oh, what am I not? I was wondering why that 0 was already there. So range is that, range 0, range 1, equals whatever this thing tells it to be equal to. This is using the size and location rather than whatever. Oh god, that's terrible, I'm using vector add thingies. That is absolutely awful. Why in the world am I doing that? I mean, I know I was lazy, but this is the thing that runs quite a lot. It's actually quite important for this to be efficient. I guess because otherwise I have to save it out as individual things. So, first thing we want to do is add those two things together. So this becomes this 0 plus that 0 1, and then we want the tile size from the scene. We don't actually have the scene, so let's just define that elsewhere. I guess in the places it's using it. Scene equals obj dot scene. Okay. Now we have that. This again would just be location. This is that plus that, and then we're adding that to that. So grab you. A can be that. A0 plus 1. And A1 plus 1. That can go away. I'll save a whole lot of time. Yes, kitty cat, I know you're here. Want a pat or something? What do you want? No? You want to walk just out of my arm's reach, okay. So, that's somewhat of a whole lot more efficient way of doing that. And we can sort of add object to things. And that is that. Okay. That VMath stuff I created loops it. There's no point creating a loop just to go through two things. You need at least 3 things, I would say. Preferably more than 3. Because I mean it takes at least 3 lines just to do the loop. It also creates a variable and all that sort of junk. So that is that. Now we have range. This will be looping through range. So yeah, I just replaced this with range. encampment around me, but apparently not. Okay. Oh wow, it's late already. Early. Sun's gonna come up soon. Can't wait for the sun to come up so I can't sleep. I don't know. I think the building site next door was pouring cement on the roof yesterday. So they probably won't be doing any work there for the next day or few while I wait for that to harden. I hope. Oh my god. It's well too bad. Are you back again? You can't yet exist. Oh. Ah, damn it, kitty! The amount of time she rubs herself on this headphone cable and then she still doesn't know what's there when she wants to run past. What's the cable? Break the headphones apart, reconnect everything back again. Why do you want to run past yourself? Alright, what was it on? So that's going to go through range. We have our location, we add that stuff to the tiles. Now we have the full range of tiles of where we are and where we're going to be. Now we just need to get the in-between stuff. So I could toss all of the vertice information through the get extreme after relativizing it towards the vector direction, and then I can get the extreme left and extreme right. And if I do that for where I am and where I'm going to be, which would both be the same vertices, so I just got to get one and then the other plus vector information. Well, that's junk. Probably don't need scales, but whatever. Then I could get the outsides of the area between. Okay. So that would give me something along the lines of that to there and this to here. So now I need to find out what tiles are on the insides of these. Or the inside of that shape. I guess in this case it wouldn't be that one, would it? It would be that one. Which isn't the same in this one because I have them both rotated. So yeah, but it would be that one. I've just drawn them in weird ways. It's actually entirely upside down, isn't it? Yeah, where is it? Okay. So how would I work out the inside? I don't know why, but I feel like there's an easy sort of way to do this. If I made that parallel along the direction of travel or whatever, then found out all of the grid tiles that would be inside of there, the grid tiles would be basically just rounded numbers, and then I rotated this thing around and then re-rounded the numbers, would that give me the correct locations? Does mean I would have to rotate every single tile, but every single tile would be rotated the exact same way, so I would just have to loop through and plus the locations, and then round. I feel like there's a better way than that, because that's... I mean, it is basically two calculations I'd have to do, but would it work is the question. I would actually need to do a test for it. How would I even test for that?
I said it before and I'll say it again.
Okay. So if the parallel version of it turned into a grid, the grid tiles were relative to one point in particular, so that would be the pivot point, which could be that one there sort of a thing. And then I could work out where that point is relative to the grid in this one, offset that by that amount in the relative direction that this one would be in, and also offset them by the rotation angle, which I could do to all of them. I believe that would tell me the tiles. That would also work with just the normal line, wouldn't it? No. Because by offsetting it back and across or something, it could be bringing more tiles up which would otherwise be missing. Or down and across would be more tiles missing on the sides on top. So that doesn't quite work. Unless I assume an offset of half a tile up and across, which would be the worst case scenario, and then add an extra lot to the side. So then when I'm offsetting it, it's going to be within a half, unless I do it by a full thing to one side, full thing to the other side. So it's either going to have 2 off one side, everything's going to 2 off one side, 1 around all of it, or 1 off one side. I mean, it would be a way of doing it. It would give me the entire interior. I could also work out what it would be. Hang on. Okay. Because the whole thing would be parallel, I'm also including bits at the top because this part might be off at an angle, and maybe the tiles, it's adding an extra row to that angle, which we're not caring about because it's just a bounding box thing. We've already got tons of stuff like that anyway. So I could work out the relative offset from this thing. I mean, I could just work that out anyway, before I even make the grid. So the grid would already be from that relative offset. Oh, whatever. Yeah, then I could just go through do it. Okay. And then when I rotate it around, would that work, damn it? I need to test this. So this is a whole other program, basically, just to test that, because I'd have to visualize it. I've made a program once before to visualize math stuff, especially that math thing, so I guess I could just run it through that thing. It's just got a spinny line that goes around the tile, like a whole lot of grids. It does. Okay, yeah, so I could visualize it on that. Okay. Let's not worry about that, and well, we got the before, we got the after, now we just need to get the in-between. As I said, we'll get the extreme ranges, which should be the same for both of them relative to the whatever, which means I just got to grab all of the vertices, rotate around the vector, and well, 90 degrees to the vector, and then get the extreme Y left right sort of thing. I've got too many brackets. Nope. I do not. Never use them. Is there a problem in here? I mean, I imagine there's hundreds of problems. I've probably done like 100 lines of code or something rather and haven't tested for a very long time. And I can't for a very long time to come. Anyway, so let's just do that. What am I doing? We've got thing, we've got the other stuff. So this is from the cat. Nice kitty, you still exist. That's the from. Wasn't there something else I had to come back to that was going to be a problem? That one. What is this? No. Oh yeah, well that's later on. From. And this one's the 2. And then I just gotta do the between. You know what? Oh, my phone's gonna run out of power. Let's put that over here. I mean, the from's basically just the from, but whatever. All that's you need to calculate. You need to calculate it too. Okay. So now I need to do the in between. Step 1, the ranges. So, but I only need the outside ones. I don't need interior ones. So I could get it by single faced edges, which I feel like a lot of things requires only single faced edges. So I feel like I should make it a variable store, like to store all of those variables. I mean, I would do it by edge loops as well, so I'd have to figure out the edge loop jump. But for now, I don't care. Let's just do it the expensive way. So, OBJ mesh verts should be fine. 4. Oh yeah, I need to store them somewhere. Verts object. For vert in verts. Verticals. Vert. XD. We only care about the locations. Oh, I guess we also care about... No, we only care about locations. Equals vert dot the actual locations. Loc A. We shouldn't be altering these or anything, so it should be fine. Oh, no, it should be fine. Okay, so that should give me a complete list of all the vertices. Then I just run this through the getExtreme. Oh, it's getExtreme. You annoy me. Why aren't you appearing? I'm pretty sure I'd used that a few times. Yeah. Whatever. getExtreme. Verts. Let's just say, no. I want range for the range, so this will just be bounds? Sure. Wait. We need the XY locations. This returns the IDs. Okay, never mind. So then we want the most left and the most right. Oh yeah, this also has to be relative to the vector, so we need to rotate that around. Yeah, this needs to be rotated around. Is it location, then rotation? I always forget. Because I got that one that isn't. And all the rest of them are, so this should be location, then rot. Yeah. So we need to rotate that around by the thing, so that's going to be what? Rot is equal to j dot vec Get rope. There to there. Okay. So that should give me the rotation. We want to add 90 degrees to this. No, I think this is fine. So if we rotate that around by that, I don't care about the 180 problem. Or do I? Damn it. Nah, this should be fine, right? It's all relative. Okay, so that should be it relative, so we've got parallel lines between the things. And if we have where it is and where it's at, we know where it's going, then we could actually... We don't actually need to run... We know what the vector is, we could just add the vector to it. So this is before vector, so... Yeah, we get the extreme, we want the most left and right, the most x. So... let's just say bounds is equal to... bounds... Wait. The pivot, but it's parallel, and with them both to rotate around the same point, which in this case is just 0. That matter? Hang on. Yes, this should be fine. I think. Maybe. We need the distance, which is just one plus the other. Now we move down, or up. I don't have to pivot around first one's things. Okay, I think it's fine. Okay. So we want to get the vert that we want. This thing should work fine with an object, I believe. So this should just give me the vert IDs. So we want the, whatever the vert is, which has the least. Yeah, let's just do it, let's just say edges. Edges is equal to the verts bound. We want the x, which is the 0. We want the least, which is the 0, and we want its ID, which is the 1. So that would give me that vertice, which is the one we want, and then we want its location. So there we go. That would be one corner of the edge, and then we want the other side, which is a little bit more complicated. So for now, let's just say it's 0, 0. So we just want the greater than, the max and the least, whatever. So edges is equal to an array with 0, 0. Yeah, what? So edge 1, xy, xy. Yeah. That's how that's supposed to work, right? So edge 1, edge 0s, first point's xy, second point's xy, yeah. Okay, so this would be edge 0, 0, and you are equal to this. And 1, 0. So we're going to pivot around that point. Let's not worry about that one then. So that would be that one's location. So the first edge's first index, first location is that. The second one is going to be this, but with the added thing, which we could just say that again, just for simple. That 0, that 1. And we've got a plus on change. Change 0, change 1. Okay. So now we're going to work out change. Change is going to be the change of the vector. No. Yes. No. We've got to rotate, we've got to pivot this point around. No, yeah, that's fine. So we just need to add change. No, because this is all relative. Okay, so that would just be vec. We didn't add vec into here, did we? No, so I guess I do it that way. That's interesting. Whatever. I'll post a join for ask questions if you want to know what's going on. So we need to add the vector to it to know what its actual end place would be. That was going to be a problem. And the vector is just the x and y combined together to get the distance. No. That's not how that works, is it? Okay. So we do need change. So we need to get the distance. Let's just go with this. We need to get the distance from just 0, 0 to j vec. And we need to add that to both of these. And that would get my other point. No, hang on, not both of them. We just need to move it upwards. I don't know why I'm just going to assume upwards. Upwards is negative in the y because confusion. No, let's not do that. I don't know why I've switched around my thinking. So we're going for the top one, pivoting around. Okay. I don't know, I went from the bottom one because it's the first one we're grabbing. So if that's where we're grabbing from, this is the one that we're going to be pivoting around. We just do this to the y, not to the x. It's the same x, but the y is offset by the distance of the vector. Okay. And then let's do 1. Then we need to get the next point, which is going to be this thing 1. So the other side of the extreme range ID. Get the vert's location, and then we need to pirate this thing. We need to rotate it around to this pivot point. No, this pivot point. That's just the way I'm imagining it. Wait, how's that work? No. To rotate it around that pivot point, we need to minus the location, rotate it, and add the location back again. Whatever. So let's just say you're equal to that. And then that 0 minus equals that 0, that 1 to that 1, And then we say that is equal to pi rho that by what rotation? By just rotation. Wait, we already did this. Wait, what? That's rotating, but that's, oh, this should be A's. We're not using this rotation, that was just to get the extremes. Okay. So no, that stuff doesn't matter. Okay. But it's the same rotation. Just a different pivot point. Notice if the pivot point mattered with that one. So, yeah, we want to rotate that around by that amount. And then we want to add this back in again. So that should be its relative location relative to the other point rotated around. So that line becomes parallel. We got that line, that's parallel. And then we have this line parallel relative to the other ones, so it would look something like, I don't know, something like that. It's lower down and lower down. So we got that first lower down part, and then we can just add on the distance for the second part. Okay. God, this thing looks confusing. Wait, did I do the 0, 1 things wrong? I did too, didn't I? That one's complete. These should all be 1s. So the second edge's first point is that thing minus this thing, that thing rotated around by that much, and that thing re-added back to this. And then this thing's second point is going to be the first one's things, x, y, with the y plus the distance. So that'll be that. Okay. So now with two edges, like this, do we need to get a bounding box? Because these could be in any order in any way. I need to get which one's the top right and top left and bottom right. To be able to get a bounding box, I need its location, relative location, and size. Okay.
Warren, I'll say it again. Life moves fast. You don't stop and look around once in a while, you could miss it.
Do I need all four corners then? I mean, because I could just get that start point and get the end point. Although I'd still have to do all this random junk for the end point. I could ignore that one, and then well, I'm going to need all of these variables anyway, just to get any 2 points, so... I mean, I think I could get rid of that one. That's the only line I could remove and still have 2 opposing points. I need the first one stuff to minus and plus, but I need the minus and plus stuff to get the bottom half of the second one. So I can't remove either of those, and this requires that one, so this is the only one that's not required the second time. Adds the least amount of my problems, so I'm just going to leave it in there. Okay. So now I gotta get the bounding box of these 4 points, I guess. I could swear this function should be in here somewhere, but okay. Why would that not be in here? This is the Mesh update. Yeah. So we get the box from the verts. In this case, the verts are that thing 0, 0, 0, 1, and 0 to 1s. So that's the 4 bits of information I have. This will return me a bounding box with the relative, with the global location, relative size. Okay. Now I need to offset this to be relative to the global grid. I think I was going to do a whole lot of testing before this stuff. Okay. Why am I not doing that? Because I don't even know if any of this is going to work, and I can't really visualize this. Unless I... Oh wait, that's literally the next step, is to visualize this, never mind. So I may as well just continue going with this. I want to be able to see all of the points of collisions it's checking frame by frame. Also, do cool sort of motion blur thing we'll do. Anyway. So we have the bounding box. We now need to offset according to the local space, or the global space. Global to this local, this is the local space. To the global version of the quick collision grid. So the collision grid, the grid, whatever. The grid, we need to find its points. Okay, so all I should do to find a point on a grid is get a location and round it and divide it? Or location, divide it and round it. I don't know. I literally have it up here. Oh, I just got world grid, okay. So I just get the world to grid of the pivot points location, which would be location. Oh. Me? Well, it doesn't matter. Just the pivot points thing, wherever that one happens to be. So that's just my 0, 0. No, that's my 0, 1. Oh, okay, so the 0, 1's the one I can't remove. 0, 0 is the one I can remove, but that one's using this one. Then, whatever. So... Okay. World to grid of this location, this tile size, and scale the tile size for optimizations. Does this give me the literal grid? Yes. Okay. So I would then just times it by this. Offset is equal to that. Offset 0 times equals that 0, 1. I never tried to do it with an uneven grid. I shouldn't care. I mean, I do use that as a double thing, right? That's rendering. Get out of here. Yeah, you use an X and Y. Should work. It doesn't render correctly though. I think rendering one's thing that doesn't. Whatever. So we get this. This is going to be our offset to the thing. So offset 0 plus whatever. Sure. Yeah. Times equals that. I could probably also then say offset is equal to, let's just say, that 0 times this. And then I want to say this minus that. No, hang on. The 1 is the one we're pivoting around. That minus that. Okay. And that minus that. So that's going to give us the difference between where it's at and where the grid tile is at. This grid is all relative to that one, so we just need to offset the first tiles. Is it paused again? Yeah. Let's make this to a playlist. Tabs are all messed up. What do we want? So we need to. If this is offset in a positive direction, then we plus. If this is offset by more than one tile. If this. Hang on. I mean, it's never going to be more than one tile. It's either going to be negative. Hang on. What? This will be a positive number. If the positive number is greater than half the tile size, then it's a negative. So if it's greater than half the tile size, then we want to minus 1 to the location's starting grid thing. And if it's greater, then we want to add it to the size. Okay. So we basically do this thing again. So we have location and size, which is gotten from our bounding box stuff. Let's keep it all close together. So range is range, location is box loc, if I remember correctly. Let's check that. Huh? Really? I could have sworn you had like location size. Do I have like another one? Oh, this is object bound. No, that's what I was looking for. Huh. Really? Okay. So no, I got the two global things for it. Okay. It's too much to even comment. So much going on right there. What am I doing? So we need to do box. Yeah, I'm just saying box loc. Oh, that's because I literally put box loc there. We need to get the box location, which is simple in this case. I feel like I should just have it typed out. So this is just going to be box equals object with loop and size. I'm getting hungry. And size is this to that, and loc is this to that. Away. Let's just move that up there. I don't know why box is all up here. Because I need to offset things according to this. Which is what offset was. Hang on, what? Hang on. So I get the bounding box from that, which gives me the location and size, but the pivot point has nothing to do with that. So let's just get that after here. So we'll get the offset and then the bounding box. So the offset should be fine. It's less than, greater than, whatever. Depending on greater than, less than. So we've got our bounding box. We run our bounding box through the range. So box loop. So we just add box dot to the things. Okay, which is now pretty pointless because that was the other. I just minused it and then added it back in after converting it to object. So I don't even really need to do that, but I'm just going to do that because standardized. Okay, so that should be my range, and then I need to say if offset 0 is less. Is greater than? What do I want equal to be? Do I want equal to be on one side or the other side? I feel like I want equal to be on the lesser side. So we're checking greater than. Okay. So if it's greater than 0.5, then range 0, 0, minus 1. Okay. Else range 1, 0, plus 1. Okay. Then I do that again, 0s, 1s. So now that should be accounting for offsets between the relative local and global grids. Okay. God, it's going to be real fun to try to reverse engineer later on when I forget how to use it in like 10 minutes. So, now that that's a thing, we should have our complete local grid with the pivot points damn it. The pivot point's not quite correct. The pivot point has got to be going from a global grid location, but we can't have it, but the object itself doesn't. We need, okay. So we need to figure out where that global corner of the grid location is relative to the local. This is sort of where it would be relative to a global. So we need to rotate around offset. We need to rotate offset around the pivot point. And that way when we pivot it back, it will line up to where it's supposed to be. I think. So this is making it relative to the pivot point. So I just say offset equals pi rho. Oh god, I've just realized this whole thing's gonna run like 100 times every frame. Thousands, possibly, of times every single frame. Oh god. Oh, that's collision spoil. I knew it was going to be a big thing. This is a heck of a lot more complicated than 3D rendering, I think. So I'm going to have worse performance than my 3D engine does, which means I've got a limit of about... Oh, for real? Oh, damn. Okay, so if this ran once with every single object, I would have a limit of about 800 edges. Damn. Because I got a limit of about 800 faces on my 3D engine. And this is a heck of a lot more complicated than rendering an entire face. So, it's going to be less than that. But it's not in total. This is only the Oh wait, no, this isn't that. This is the This depends on per object, not per face. Never mind. Per edge. It's simplifying just to the left and right most vertices to create this stuff, so... Okay. Well, I mean, if that amount of objects, that's a different thing again. But then this has to run every single increment of the collision check, so... collision updating increments. So I could have an object, a single object, either bounce, like, less than 700 times, well, let's just say 500 times a frame, or 500 objects not hit anything a frame. I don't know. I wonder if I could pass this off to them. No, I can't. Can't pass this off to a multi-threaded thing. I mean, I guess I could. No, never mind. Maybe? I mean, I could actually, because the complicators will... Again, I don't know. I can't deal with any instanced information, that's the problem. Whatever. What am I doing? So I'm pi-rotating this thing around by the negative of the rotation, or is it the same? It's just the same rotation, isn't it? So pi-rot offset by rot, and this is technically already relative to 0, so that's that. We go through. Now we have our grid locations with the top right relative corner to the global grid. Okay. Well, this is going to take me days to debug. And now we need to rotate all of the tiles around. Okay. Hang on. So now I need to get all tiles within this range, put them into a list, offset their locations by the pi-rot, which I could just get whatever the change is to one of them, and plus that to all others, so I don't have to do the pi-rot math for every single one, and round them. Floor them. So... check. Hang on. No, we're going to be doing this thing again, aren't we? We'll be doing the top one. Although this time we don't know if the tiles exist or not, so we'll have to do an extra loop outside. But then if we were doing an extra loop outside, let's do an extra loop outside. Let's grab all that. So this has to loop through that range, so the ranges X and Y, you should be all the correct numbers. Then we get our tiles locations, but we don't want it to add it to this list, so just say tiles A. In this case, we just want it to be an array because we only care about the literal locations. So we're just going to be pushing that. Oh wait, hang on a second. No, we can just do it all at once, can't we? So let's use offset again. Offset equals... Oh. I can't just do that, can I? I do need to pyro... No, there must be a better way than this. Because the further away from the pivot point, the more it needs to rotate. But to get the distance between one point and the other, I may as well just do the pyro thing, because it's somewhat the same math. But this could be a massive, massive amount of stuff. Damn it! That's the whole point of this, is to avoid all that. Okay, in that case, there's another more simpler solution to all of this. More simple than looping through every single point and pyroting it around anyway. And that would be to just get the edges stuff and then rotate it around. And then loop through every extreme right to extreme left of the top two. So I want to get the top two. But we don't know direction. It might not be the literal top two. It could be going sideways. It could be going downwards. No, it doesn't matter. The top two... so we just do the pyro thing with the diagonal sides. And that's all we need. We don't need the interior things. Then when we... once we've rotated around, we get those tiles from the left side, from the right side, or whatever. No, we just get all the tiles. We get extreme, we get the top ones, the top two. Or the top two? Top three? Top three. So if we get the top three, then we can get the very top one, and the second top one, and the third top one, and we see if the second or third one is closest to the top one, and... how do I do this? And then we get the most extreme left to right, we draw a line. So... whatever. So the top two, this one and this one's up and down, Y is basically the same as this one, it's closer than that one. So we can draw those together. And then we could remove this one. Okay, so I'd have to get to the top. I need to get the top three to get the one the most to the right, and then check to see if it's Y is closest to this one or that one. Draw a line across, forget about that one. So that one gets deleted from the list. Then we get the top three again, we get the one that's most to the right, which would be this one. And then we get the one that's the highest... No. There should always be two with the same level, never mind. It's weird. Yeah, so we just get the top two, No, we just get the top one. No, the top two. One of them will be the most right, the other one will be the most left. So you get the extreme for the top two, then we get the extreme for the top two's left and right, and then that would draw a line. Then we forget about those, do it again and again and again, and we should be able to get the ranges between those things. There we go. Because there could be any crazy shape with like thousands of lines just going and like thousands of faces on it just going in every whatever. It's like it could be thousands of different things in between here. Tiles. That way we don't care about the inside stuff, it's just the outside stuff matter. It's still doing the pyrote thing though, which is still a pain. Okay, so this is just all basically bringing me back to... I need to work out the best way... Because I've done this before, but it didn't work. It wasn't entirely correct. This is where I was up to with my 3D game engine too, because I need to optimize the rendering so you only see the faces in front, you don't see the faces behind. It occludes the faces behind so they don't get rendered. So I need to figure out the occlusion. If I get the grid tiles in front, and are they overlapping one behind? Anyway. So... yeah, I think I need to do that. Okay. So what am I doing? Yeah. So basically I need to figure out all tiles that an arbitrary shape is covering. I can't move on till I've done that. And that feels like an entirely separate project I'll have to start up to mess around with math and code for that. And I'm going to do a whole lot more theory stuff again. Is there anybody here? Is there anybody watching? Apparently there's 2 people here. Are you actually here and watching? Shall I continue, or am I going to go get some food and then maybe not come back? Till tomorrow. If there are people here and watching, then I will continue going. Okay then. So yeah, I guess I'll do that when I come back. Open up that math project. Actually, let's just have a look at that before I go. Where in the world did that go? What the world would you be on though? Tests, I guess? No? Sim? Nope. Huh. Visualizers, there we go. Because it was a math visualizer. What? Why don't I see it? I'm confused. Hold on, games, is it? No. Huh. Okay. Performance test? What the world are you? I don't remember this one. Okay. Doesn't seem to be anything. Maybe it was a project I was going to do and then didn't. I have no clue at this point. Mathbits, there it is. It's hiding with music, only a few letters off. There we are. So that's my intersecting line math. From the original stuff, anyway. But it only works if this starting point is exactly on the intersection of tiles. Never figured out how to do it with the offset. Well, it seemed like it should be a simple thing, but it never worked. But anyway. So I'm going to think more about that code. Maybe I'll think of some better solution of it, because I'd rather not have to do the pyro for every single damn one of those things. Because that's going to be well too laggy to probably do anything of actual use with. So, okay. Okay, thanks, bye.